So our quadratic can have two solutions, one solution, or no solution. Those are our three possibilities. Okay? What we've seen in the past, remember when we did factoring and quadratic formula and all that? Quadratic formula told us when we had no solution. When did that happen? If you were trying to take the square root of what kind of number? A negative. That's a no solution case. What that picture looks like is that you would either have a quadratic that looks like this. Why would that be no solution? Doesn't touch the x-axis ever. It's going up, and it's never going to touch the x-axis. The other situation you could have no solution is something that looks like this. Because that one is opening down and would never touch the x-axis. Those are both situations in which you would have no solution to this. Okay? Anyone have any ideas how you get only one solution? Okay, how do you make a U shape only touch once? At the very bottom. So what point did we call that? The vertex, the maximum or the minimum. So it could look like this, where literally the quadratic just touches at the vertex, or, again, it could look like that, facing upwards or downwards. Two solutions is easy. It's any kind of quadratic that just crosses twice. So you could have a U facing up that crosses twice here. Yes, some of our homework had solutions to them. Yes. Or it could look something like this. They don't have to be on certain side of the x and the y axes. I'm just trying to show you a picture of both so that you see them. Okay? So the good news is literally the only thing we're adding to what we did last class is saying, where does this cross the x-axis? So you're graphing this the exact same way. So if you need a little more practice with it, you got it. If you don't, sorry, but you're getting it anyway. And we're just going to see where it crosses. So if I was to graph number 1 here, let's review the process. Where do we start? Okay, we do our A, B, C. We know A is 1, B is 4, C is negative 5 in this case. What do we find first? Negative B over 2A, which gives me my axis of symmetry. So my axis of symmetry is at negative 2. So I draw a line on my paper at negative 2. Vertical line. And there's my axis of symmetry. It's a little bit off there. After that, how do we find the vertex? Plug in that x value to find the y value. So I would do negative 2 squared plus 4 times negative 2 minus 5. That's going to give me 4 minus 8 minus 5. Negative 9? Yep. Okay. So if I have a vertex at negative 2, negative 9, where do I put that in my table? Yeah, let's just use these 5. Or how many is there? 1, 2, 3, 4, 5. There's 7. We don't need to do all of them. Well, we might. We'll see. Hang on. Let's put it in the middle still. There may be a reason why we need this on this one. And I think I know what it is. All right. So if they give us a table like this, okay, typically we do 2 points below, 2 points above, right? So if I do 2 points below this, it would be negative 3 and negative 4. 2 points above that would be negative 1 and 0. Which ones should we probably plug in? Negative 1 and 0. Okay, those are pretty easy. 0 is negative 5, so where else is going to be negative 5? The top one. And if I plug in negative 1, I'm doing negative 1 squared plus 4 times negative 1 minus 5. So what am I getting out here? 1 minus 4 is negative 3, minus 5 is negative 8. All right, so here's why all of a sudden we have more points on this one. Because if we graph these, negative 4, negative 5, negative 3, negative 8, the vertex is down there at the bottom. So I graph all of my points. If I want to solve this one using graphing, right now, do I know where it crosses the x-axis? Because right now, I just have this, right? Does that U shape, the way I have it drawn, cross the x-axis?
Yeah.
I mean, it's going to. Do I know where? No. And personally, I don't trust my drawing skills enough to think like, oh, I know what I'm doing. I can just pull that up a little bit further and take a guess. Who knows? I don't know where it might cross. So what you do in that situation is you keep plugging in some numbers further out. So what's further out than 0 and -4? 1 and -5. Again, I'd pick the easier one to plug in. Let's try 1. So if I plug in 1 to this one, okay, 1 squared plus 4 times 1 minus 5 gives me 0, which is exactly what I'm looking for because I know, what does that mean? It crosses the x-axis there. So that means both at -5 as well as 1, that quadratic's going to continue out and cross. Now, graphing is not always going to be your best method to solve. Because if we have decimal answers, is it going to be real easy to see if they cross there? No. Okay? This is personally not my favorite method of solving, but we will practice it so that we know. How many solutions do I have here? 2. What are they?
-5, 1.
Yep. So my official answer to this, I have to erase my work here, so just stick with me. I didn't slide down enough on my paper. My official answer to this would be that there are 2 solutions. X equals -5, X equals 1. Those 2 answers would be my answers. Now, tying this to something that we did before. We had other ways of solving. Last chapter we practiced 3 different ways. Someone name one of them. Factoring. Other one? Quadratic formula. And? Square roots. Okay? This one, I'm not going to make you do it right now, but if I factored that one using the box, it would factor into x plus 5 and x minus 1. How did we find our answers to that? Take your factors and what? Set them both equal to what? 0. If I set this equal to 0, what do I get? -5. If I set this equal to 0, what do I get? 1. Anything that we recognize with that? Same answers? If I solve that quadratic using factoring, quadratic formula, can't solve it using square roots, or graphing, I'll get the same answers.
So what's the point of doing that?
Some of them are easier than others to solve different ways. So we learn different methods.
But how do we know which method to use?
On SATs and ACTs, typically they'll give you one that's particularly helpful in one way, shape, or form. Like if they make you do graphing on your SATs and ACTs, they will give you a graph and not even give you an equation like this and ask you what are the solutions to this. So then you're just looking for where, they want you to know that I'm looking for where it crosses the x-axis. That's all they're asking to test you.
A line?
It would give you the U shape on a graph and ask you the solutions. Yeah, I've seen that kind of question. It's not a difficult one, but if you don't know what the solutions of a quadratic are on the graph, you can't answer it. Because they'll give you stuff that's like the vertex or other points and stuff like that. So they'll give you other important parts of it, but they're just asking you to know it. That's all. It's also helpful like for word problems. Like remember there was that one on the front of your test that had the quadratic going down and it said when is it going to cross or when's it going to hit the ground?
I think I missed that one.
Okay, that was literally asking you for where it crosses the x-axis there.
Oh,
so it took a word problem, but it made it real easy if you knew what the graph meant on that.
I got that right, didn't we?
Yes, sir.
Can you?
All right, let's practice that again with question 2 here. You will not always have to do the 5 points. Okay. So on question 2, where will we get started? What do I start with in question 2? Negative b over 2a, so 2 divided by 2 times 1, which gives me what? 1. So that means my axis of symmetry is at 1. It also means my vertex is the point 1 something. We just don't know what that is yet. Okay, so to find that, I plug in 1. 1 squared minus 2 times 1 plus 1. What does that give me for the vertex? 1 what? 0. Because that's 1, 0, what does that tell me already?
It crosses on the 0 or -1.
Okay, that's going to be one of my solutions because that's where it crosses. And if it's the vertex, it's going to be my only solution. Because when the vertex touches, that's the only place. But we can graph the rest to see it. That's always in the middle. Yep. Then we graph the rest of this by picking 2 points below 1 and 2 points above 1. So what x values are we going to plug in? Below 1. 0 and -1. Above 1 will be 2 and 3, right? I would personally plug in 0 and -1 because to me those would be easier. If I plug in 0, what am I going to get back out? 1, which will match next to what number? 2.
Number 3.
Okay. And if I plug in -1, I get out 4. Yep. And 3 is going to be 4 as well. If I can graph those 5 points and see where it crosses the x-axis, I don't need to go further out. So in this case, if I graph these points, I have the point 1, 0, 0, 1, 2, 1, -1, 4. So in this case, where does that quadratic cross or touch the x-axis? Okay, at 1. So how many solutions does this have? 1 solution at x equals 1. Okay? Issues with that? No? We won't have to do many more of these, I promise. All right. Let us try the next one. Okay, take a minute on your papers and graph this one. You know how to do that from last class. So if I can see from my graph that it opens down, it's going to continue going down, and it's not going to cross the x-axis ever, what's my answer officially to this? No solution. Where does it cross the x-axis? That's the y-axis. Okay, so we're looking only for where it crosses this up here, right? Now we've done one of each type. One with 2 solutions, one with 1 solution, one with no solutions. Do we need to continue practicing that? Or are we okay? All right. We're going to flip past a couple things here. Okay, this page right here, quadratic roots. This one. Shh. This page, 1 through 9 is your homework. Do not cross off 10 through 15. We will come back to 10 through 15. I'm just not giving you that as part of your homework. Then you did. So there's that. We're going to do one other thing quick, and then you will have time. Okay? This was just passing on the way there. Okay? All right, one other thing we're covering today. Flip till you find this page. It's like 2 pages over. Quadratic equations in vertex form. This will be the final thing we're doing today. There are 3 questions here and I'll be done. Yes, I know. I'll probably use it for a warm-up. Flip a couple pages over till you find it. I mean, I could tell you it's page 5, but they're not numbered, so it's not going to help you. I don't even know if it's page 5. All right. Last thing we're doing today is quadratic equations in vertex form. Okay? We have talked about so far this form. Whoops, not that. Okay. Y equals ax squared plus bx plus c. This is called standard form. There are 3 forms of quadratics. We are only talking about 2 of them in this class. Okay, standard form is the main one. Vertex form is this one right here. Okay, so first thing we need to be able to do is just, if we're given an equation, tell whether it's in vertex form or standard form. And in order to tell that, there's just a couple things you have to notice about it. What's one thing that you notice that's in vertex form that's not in standard form? Parentheses. That's the dead giveaway. Okay? Notice if you look at this right here, that's got parentheses around the x minus 2. The squared is not directly next to an x. Okay? So this tells me it's not standard form. It has to be vertex form. All right? Yep, the parentheses is vertex form. Things that we know from vertex form. Let's review standard form quickly. Standard form, what did this a value out front tell us? It told us the a in the finding the axis of symmetry. It also told us what? Whether it opened up or down. A in vertex form tells us the same thing. Tells us whether it opens up or down. Okay? You can convert this back to standard form. I don't, because I think it's helpful to be able to graph this, and it's easier to graph. So, I keep these in vertex form and graph from there. That's personally what I do. Also from this, whatever number is in here with the x is called the h, which is the x value of the vertex. Whatever number is in or out here is called the k, which is the y value of the vertex that we get there. So literally in question 1 here, if you compare this right here to vertex form up there, what is the h and what is the k? 2 and 3. Notice that in the formula, here's the big important thing. There is a minus sign in the formula. That means when I pull out that h value, I'm going to do the opposite of what it says. So if it says minus 2, my vertex is positive 2. Because you're only pulling out the number, not the negative. That's the x point of your vertex. The y point of your vertex is, what's the other number, the k? 3. The 3 does not do the opposite because there's no minus sign with the k. So we do the opposite of the h and then the k. That's literally your vertex. So 0 work. We just pull it out of the formula. That is why I don't switch this back to standard form, because you'd multiply it out, switch it to standard form, then plug it in to find the axis of symmetry, then find the vertex. I think that makes it harder. Why not just pull out the numbers that they're given to us? Now, what this does do, though, is it makes us work backwards to find the axis of symmetry. Okay? You don't actually have to do any work for that, right? Because what does the axis of symmetry match? 2, the vertex, the x point. Okay, so as long as you remember that, that's no work either. So far we have our axis of symmetry at 2 and our vertex at 2, 3. All right? That goes in the middle. The rest of it you finish just the way that we did before. We plug in 2 numbers below 2, 2 numbers above 2. So what number should I plug in for x? What are the numbers below 2? 1 and 0. And the numbers above 2? 3 and 4. They're going to match on either side, just like before. So I'd plug in 0 and I'd plug in 1 if I were you. So if I plug in 1, now this one you just have to be a little careful of the format. Order of operations would say I do what first in this? The parentheses. So first I do 1 minus 2. That's negative 1. Then I square negative 1, which gives me what? 1. Then I add 3, which gives me 4. That matches down at the 3. Do the same thing if I'm plugging in 0. 0 minus 2 squared plus 3. So I would first do the parentheses, which would give me 0 minus 2 is negative 2. Then I would square the 2, which gives me what? 4. Then add 3, which gives me, okay. So we graph our points just like we did before. 1, 4, 3, 4, 0, 7, 4, 7. This one, if we were asked to solve it, which this one we're just graphing, but if we were asked to solve, this would be a no solution because it doesn't cross. Okay? Does it cross the x-axis? Down here. That's the one we're worried about. Domain for this? Negative infinity to infinity. Range for this? Bottom to top. What's the lowest value? 3 out to infinity. Okay? Let us try that one more time. Okay? Because I want to practice finding the vertex out of the formula that you're given. So in question 2, okay, remember the vertex when we pull it out is the number in with x and the number at the end. So what number am I pulling out of the parentheses there? Okay, it's going to be -3 there because I use the opposite of what it says in the parentheses. Right, because the formula had a minus in it, the minus and negative turned into a plus, but they don't show you that. So you just have to remember to do the opposite. So we do the opposite of the x value. We do not do the opposite of the y value. So what's the y value there? -1. That is my vertex that goes in my table. What's going to be my axis of symmetry? -3. All right, so take a minute on your paper here. Take a minute on your paper. Finish out your table. -3, -1 is your vertex. You're going to finish out your table and graph the rest of that real quickly.